So how do you know if an AI is actually any good? I mean, it's a question we're wrestling with today with every single new model that comes out, but it turns out we're not the first ones to ask it. So today, we're going to jump back in time, all the way to 1987, to the dawn of commercial AI, to see what we can learn from the past about a problem that's, well, more relevant than ever.
Okay, so picture this. The year is 1987. The hot new thing in tech is something called an expert system. The Rand Corporation, the famous think tank, they gathered all the top minds in the field to answer one huge question. How in the world do we know if these new thinking machines are any good?
So what were these expert systems anyway? Well, imagine a piece of software that was designed to mimic the decision-making and problem-solving skills of a real live human expert. It could diagnose a problem, classify some information, or even plan a course of action. I mean, for the time, this was basically science fiction jumping right off the page and onto your computer screen.
And that was the big problem, right? You've got all these new AI tools flooding the market, but how do you measure them? How are you supposed to evaluate a piece of software that's meant to think? There was no rulebook, no standard, no guide at all. They were flying blind.
So inside these RAND workshops, you can just imagine the debates. The field was so new that, and this is a quote from the report, it lacked well-established definitions. You had features with similar names that would work in completely different ways depending on the tool. It was kind of like trying to build a house when everyone had a totally different idea of what an inch was. They desperately needed a common yardstick.
So they started brainstorming some approaches. Maybe they could compare tools against each other, or run them through some small standardized tests they called benchmarks. They could do deep dive case studies. Somebody even suggested creating a consumer report-style guide for AI. But every single one of these methods just ran smack into the same wall. Without standard definitions, any comparison was just apples to oranges.
Now, this is where it gets really interesting. This graph shows that the definition of a good tool wasn't some fixed target. It actually changed over time. So early on, when you were just figuring things out, clarity was king. You just needed to understand what the tool could do. But then, during prototyping and design, flexibility suddenly became the most important thing. And way down the line, once the system was up and running, well, then you cared about vendor support and efficiency. A tool that was perfect for day one could be absolutely terrible for year one.
Faced with all this complexity, they got pretty creative. My absolute favorite is what they called the Rolodex technique. I'm being serious. The best way to evaluate a cutting-edge, futuristic AI tool was to flip through your business cards, find somebody you trusted, and literally call them up to ask, hey, have you used this thing? Was it any good? It was word of mouth for the burgeoning digital age.
And this brings up another huge issue. What you needed from a tool depended entirely on who you were. A novice user, they were worried about the cost, if it had good documentation, and how hard it was to learn. But an expert developer? Totally different story. They cared about deep system access, integration with other software, and multi-user support. The takeaway was clear. There was no single best tool, only the best tool for a specific person doing a specific job.
So, why are we digging up this 35-year-old report? It's because the technologies, they've changed completely. But the fundamental challenges of managing expert knowledge, those never went away. They just evolved.
Just think about it for a second. We still struggle to make sure our systems are reliable and consistent. We still demand clear explanations for why a system does what it does. That's a huge topic today. We still need to support different kinds of users and integrate with a bunch of other complex systems. And the challenge of handling massive amounts of data and managing updates? I mean, come on, those problems are bigger than they've ever been. The experts in 1987 were basically looking at the blueprint for the challenges we all face today.
And this is where the story takes a really fascinating turn. Because while those early AI expert systems are pretty much history now, that quest to solve these big problems of knowledge management didn't just vanish. Nope. It shifted into a new and incredibly important field, managing the complex technical information that makes our entire modern world run.
Okay, look at this. On the left, you've got a simple text-based problem from that 1987 report, and on the right, that's a modern content management system. The technology is worlds apart, obviously, but the core task? It is identical. Structuring complex knowledge so that a system and a person can understand it and use it correctly. This modern tool is the Content Management System, or CMS. The easiest way to think about it is like a super smart digital manual. It's a tool designed from the ground up to capture, manage, and deliver expert knowledge, not for an AI, but for the highly skilled people who operate, maintain, and repair our most advanced technology.
So let's stop talking in hypotheticals.
Let's see what this looks like in the real world. We're talking about knowledge in action, on the factory floor and even in the hospital. Today's complexity lives inside machines just like this one from Chiron. This is a high-precision manufacturing center. The amount of knowledge you need to operate and maintain it is just immense. A mistake here isn't a software bug. It's a very real, very costly physical error.
Or take this MRI machine from Siemens Healthineers. Here, the stakes are even higher. The documentation has to be absolutely perfect. It has to be legally compliant with strict standards and available in up to 40 languages for hundreds of editors working on thousands of product variations. This is knowledge management where accuracy can literally be a matter of life and death.
So how do these modern systems solve those timeless problems we've been talking about? Well, they don't just give you a PDF manual and wish you luck. The information is integrated right into the machine's control panel. The system actually knows the machine status and automatically shows the operator the exact instructions they need right at that moment. This is how you get the right information to the right person at the right time. This is how you guarantee reliability and accuracy.
So when you connect all these dots, you see this really clear, unbroken line stretching from those workshops in 1987 all the way to the smart factories and advanced medical labs of today. The quest to manage complex knowledge is exactly the same. This has always been the goal. It doesn't matter if you're an AI programmer in the 80s or an information architect today, this is the mission, to deliver clarity in the face of overwhelming complexity.
So the next time you see a really complex piece of machinery, or you benefit from some piece of advanced technology, just remember that behind it all is this decades-long, very human challenge, the quest to capture, manage, and share expertise. It's a quiet but absolutely essential engine of progress.
Which leaves us with one final thought to chew on. Those expert systems from 1987, they're museum pieces now. So looking at the cutting-edge tools we all rely on today, which ones are just solving a temporary technical problem, and which ones are actually tackling a timeless human challenge? Because one of those is going to end up as a historical artifact, and the other one, well, the other one is just going to keep evolving.